Hello everybody, today we are going to see how to use an ammeter. First, you can subscribe to the YouTube channel for follow the next video, and you can find this course in a written version. You will find the link under the video. Multimeters have an ammeter function. The ammeter is used to measure the intensity. It is, however, necessary to disconnect the electrical circuits to install it in series. By making the analogy with hydraulics, the intensity represents the flow of electrons. To measure this flow, it is necessary to have a meter in a series on a circuit. It is the ammeter. The intensity of an electric current is expressed in ampere or milliampere. Depending on the multimeters used, it is necessary to change the location of the test pin. In all cases, the current measured must be estimated in order to calibrate the multimeter in the correct position. Here, the multimeter is calibrated on 400 milliampere maximum in direct current. Here, the multimeter is calibrated on 400 milliampere max in alternating current. Here, the multimeter is calibrated on 10 ampere maximum in direct current. On this type of device, you must move the red test pin. Here, the multimeter is calibrated on 10 ampere maximum in alternating current. On this type of device, you must move the red test pin. In Figure A is shown a simple electric circuit consisting of a battery. The plus terminal is connected to the switch by wire 1. The wire 2 is removed to install the ammeter. The consumer is connected to the battery ground. When the switch is closed, the bulb lights up. The value read on the ammeter corresponds to current entering the consumer, flow of electron. In Figure B, the same electrical circuits, the ammeter has been moved to the consumer outlet. It can be seen that the intensity is the same on entry and exit. In Figure C, two identical consumers are installed in parallel. The ammeter is positioned in 4 places on the electrical circuits. The first, at the common arrival of consumer. The second one, at the exit of the first bulb. 3. At the exit of the second bulb. And at the common exit of the consumer. When the switch is activated, we see that the input current, 2.4 ampere, divided into 2, 1.2 ampere, because the consumers are identical. The output intensity remains equal to that of the input. If the consumers are different, the intensity divides inversely. For example, 1 ampere and 1.4 ampere. But the output intensity remains equal to that of the input. It is Kirchhoff's current law. The sum of the currents which enter an electrical node is equal to the sum of the currents which come out. Be careful when using the multimeter as an ammeter. It is imperative to insert in series on electrical circuit. Any measure taken in parallel can cause a short circuit. The ammeter behaves like a shunt. It is protected by a 400 mA or 10 ampere fuse, depending on the rating and the multimeter used. Immediately after using the multimeter as ammeter, it is recommended to reconfigure it as a voltmeter and to put the test pin back in a correct position in order to avoid forgetting and to risk short circuits during the next measurement. For currents to measure greater than 10 ampere, example starting circuit, it is necessary to use an ammeter clamp. This clamp has the advantage of requiring the opening of the electrical circuit. It's the end for today. Don't hesitate to ask your question, and you can find my other service, training, advice by visiting the website. See you soon for a new video.